So if we're going to look at negative 21 pi over 4, first of all, remember I told you guys to write these. If we can write them as our period, as a term of our period c, then we're going to get the same angle. So first thing I want to do is talk about what do we want to cancel out. We want to take out the 2 pi's, right? So 2 pi, or since we're dealing with the negative, 2 pi is equivalent to what pi divided by 4? What number do I have to have in my numerator for this to be equivalent? 8, right? And obviously, we're talking about negative and negative because this is a negative problem. So I need to have negative 8 pi over 4. Yes?
What are we trying to find?
I'm going to show you in just a second. What we're trying to find is a simpler way of solving this. Because if you're going to do your, let me go through the answer first, and then I'll show you the old way that we worked on these. Yes?
Why would it be negative 8 pi over 4 whenever that's negative 21 pi over 4?
Just hold on. I'm just trying to have a side statement. Is negative 8 pi divided by 4, is that equivalent to negative 2 pi? OK. And you remember our last video, we were looking at 2 pi's, right? We tried to add up as many 2 pi's as possible. So just hold it with me. I'm not done with the problem. Let me get started with it, Jacob. So what I want to say is, can I write this as an addition problem using 2 pi? Well, I'm not going to, since I have a denominator here, I'm not going to use negative 2 pi. I'm going to use negative 8 pi over 4. Just follow me here. So let's say sine of negative 21 pi over 4, that is equivalent to sine of negative 8 pi over 4 plus negative 8 pi over 4 plus negative 5 pi over 4. Do you guys agree with me? Let's add them up. Negative 8, negative 16, negative 5 is going to give you negative 21. Are these equivalent? Yes. Do you follow that, Nico? Do you follow those are equivalent? Now, what does negative 8 pi over 4, where does that take you? It just takes you back to where you started, right? It's just a circle. It's just a revolution. So that's all it is. So do we need to keep on counting our revolutions? No. So we can just cancel these out. So therefore, all we need to do is evaluate for negative 5 pi over 4. Now, where's negative 5 pi over 4? Well, that one's pretty easy to do. Right? You draw a unit circle, break it up into fourths. So you go in the negative direction, negative 1. So negative 1, 2, 3, 4, 5. So there's negative 5 pi over 4. What is that point? You guys got to start knowing by your unit circle by now. You guys got to remember, if the distance from your x-axis to there is pi over 4, in that first quadrant we learned square root of 2 over square root of 2. So this one, the x-coordinate is going to be negative. And then, what am I trying to find? The sine of that is going to be the y-coordinate of that. So the y-coordinate of this point is positive square root of 2 over 2. All right, let's look at it the old way without using period of pi. Before you guys did your homework, let's look at how I'd expect you guys to do this before. So you do the same triangle, right? You'd cut it into quadrants or into fourths. Then in negative 21 pi over 4, if you guys didn't do this math or you didn't understand this, you'd have to do this. Negative 1 pi over 2, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi, 10 pi, 11 pi, 12 pi, 13 pi, 14 pi, 15, 16, 17, 18, 19, 20, 21. You guys get to the same point. They're coterminal angles, right? I'm just adding 2 pi's to it. These are coterminal angles. They start at the same point and end at the same point. All I'm doing, or all I'm showing you how to do, is eliminate all that circling. And that circling is just eliminating your 2 pi's. Okay? And just seeing how many times you revolutionize, or you're taking revolutions or periods and just canceling them out. Does that kind of make a little sense? It's not anything that is amazingly new, but it's just something that kind of